Welcome back. The final transformation that we'll learn in Unit 1 is dilations. And dilations are different from the first three transformations in that they actually change the size of the shape that we are dilating. So it won't create a congruent figure. It will create these things called similar figures, which are figures that have the same shape, but not necessarily the same size. So they can be the same size, but they don't have to be in order to be considered similar. Now, how dilations work is we take a scale factor, or k, and we multiply the original by that scale factor. You've probably done this before. However, what we're going to be doing is a little bit more in depth. Now, just to set an example of the difference between two congruent figures and two similar figures, on the left here I have two triangles. They're the same shape and they're the same size. Right? This could be a translation. It's just translated to the right, let's say 5 units. Whereas the one on the right, this is a dilation. The size of the triangle is changed, but the shape and the angles, my drawing notwithstanding, are the same. So it's the same shape, but just a different size. Now, when we talk about dilations, there are these additional terms we need to know about. There's enlargement and there's reduction. Enlargement means to make it bigger, and reduction means to make it smaller. Now, as I said, when we perform dilations, we multiply the coordinates of each vertex by the scale factor k. We're just going to be multiplying today. When k is greater than 1, we're going to make the shape bigger. It's going to be an enlargement. When k is less than 1, it's going to make the shape smaller. It's going to be a reduction. So here we have these two coordinates. We have a starting at 0, 2, going to a prime at 0, 6. So we'll take the new and we'll divide it by the old. So that's going to be 6 divided by 2, and that gives us a scale factor of 3, meaning this is an enlargement, which makes sense. When we look at this graph here, I start with this red triangle, and it enlarges into this new triangle. Another way of doing this without needing to go through the hassle of the coordinates is to look at the side lengths here. AB is only 2 units long, while A prime to B prime is actually 6 units long. And we get the same math, right? What times 2 gives us 6? Well, 3. Okay, so let's identify some types of dilations and find the scale factor here. So let's look at 9 here. So 9, we have E to D. There's a lot going on, but we can just pick any side length. We have 2 as the E prime to D prime, and E to D is 4. So we started with 4, we ended up with 2. So again, we divide the new by the old. 2 divided by 4 in our calculators would give us 0.5, or 1/2. So k equals 1/2. 1/2 is less than 1, so this is a reduction. Okay, now let's actually do a dilation. Okay, so let's label these side lengths here, or these vertices I should say, P, Q, and R. And we're going to write their coordinates on this side. So P starts at 5, 10. Q starts at 10, 5, and R starts at 10, 10. So P, we're going to multiply by our scale factor, which is 3/5. So we're going to take 5, multiply it by 3/5, and that's going to give us P prime, which is at 3, 6. When I do the same thing to Q, I'm going to get Q prime at 6, 3. Finally, I do the same thing to R, multiply it by 3/5, and I get R prime is at 6, 6. Now 3/5 is less than 1, so we expect to see a reduction. So we should see the size of the figure to get smaller. So 3, 6, this is P prime, Q prime is at 6, 3, and R prime is at 6, 6. We can also see that this side length started at 5 and R to Q became 3. So we can see that reduction. Now, how do we write the rule for dilations? It's actually quite simple. We're going to take xy, and it will become 3/5 x, 3/5 y. And that's how you write rules for dilations. It's extremely simple. Okay? So do dilations change the shape or size of the image? They change the size. And that means that if a figure is dilated, the image and pre-image are similar. And that is dilations. Thanks for joining me.